All right, what's up guys? In last week's video, we went over a light switch, a simple state chart with two states and one event. For this week's demo, I want to step it up a notch and create a traffic system. Imagine being able to control traffic lights, pedestrian signals, and emergency modes. By the end of this tutorial, you're going to learn how to wire this whole thing up using XState and SolidJS. So here's the plan. First, we're going to design a state chart using Stately AI's XState visualizer. We're then going to port that code over to XState. Then going to copy that code over into our application that we're going to wire up using SolidJS. So let's think about a traffic light system. Typically, there's three modes at the root level. We have the operational mode that will have our green, yellow, and red states. We'll also have a flashing mode that we're going to use for emergencies and maintenance. And we also have an off mode, which we'll use to turn off the traffic system. So let's go ahead and add those three states in. Now that we define the three states, we need to also define the events that are going to be used for the transition from state to state. So for the operational mode, we're going to define an event to flashing. We're going to call this enter flashing mode. Then we're also going to define an event from the flashing mode to go back to the operational mode. Now, we also need to define an event that's going to cause a transition to the off state. We want this to happen anywhere in the traffic system. So if the state is in operational or flashing, we should be able to turn off the system. So what we're going to do here is we're going to define an event at the root level of the traffic system. And we also need to define an event from the off state back into the operational state. Now that we have the three modes defined in our traffic system, let's go ahead and simulate this to make sure that this is working correctly. So upon the initial load of the state machine, you see that we are in the initial state of operational. In order for us to go into the flashing mode, we have to explicitly send the enter flashing mode to the state machine. And then to go back to the operational mode, we need to use this enter operational mode event. Now, let's make sure that the power loss event also triggers the state transition to the off state. Awesome. Now, the very last thing to check is to make sure that we can power this back on. Sweet. Now we have our three modes working correctly. So we're going to take this a step further and we're going to dive deeper into the flashing state next. So let's think about the flashing state. What needs to happen here? Whenever we're in a flashing state, the traffic light will flash a yellow light every second. So we need to create two states within the flashing state, two child states. They're going to be on and off. This is going to be very similar to the light switch demo that we worked on week 1. So we're going to create two states and add this into flashing. Now that we have the two states defined in the flashing state, we need to use an event that's going to cause the delayed transition between off and on and off. This is a special event type in XState called after. So you can see here, when I change the event type, we can provide milliseconds to this delay. We're going to bump this up to 1000 milliseconds because we want the state to transition from off to on every second. And then we're going to do the same thing from on to off. Now that we have those two states defined in flashing, let's go ahead and use the simulate feature again to make sure this is working properly. So we start off in the initial state of operational. We need to enter the flashing mode. So we'll send that event. And you see here now we're inside the flashing state. And after a second, we transition from the flashing off to flashing on state. We can even go to the simulation controls here and you can see the actual states. See, flashing on, flashing off. Now, we need to take this one step further and dive deep in the operational state. We still need to define the three phases that occur in the traffic system, which is the green, yellow, and red phase. So let's go ahead and do that now. Now that we have those three states defined, we need to add the events that are going to cause those state transitions from state to state. This is going to be very similar to the flashing state where we're going to add those delayed events. We're going to bump up the delay for 2 seconds for each state. Awesome. Now that we have those three states defined, let's go ahead and simulate this to make sure that it's working. So you can see that we're now in the operational state, and within the operational state, after 2 seconds of a delay, we transition to yellow, to red, and back to green, causing the continuous loop. Cool. Now that we have these 3 states defined in the operational state, let's dive deeper into the red state. We need to define the states for the pedestrian. This is what we're going to use to allow the pedestrian to cross the street safely. So we're going to have 3 states that the pedestrian is going to use. We're going to have the halt state, which they're going to use to make sure that it's safe to cross the street. Then we're going to have the walk state, which will allow the user to cross the street safely. Then we're also going to have a flashing state that's going to prompt the user to make sure they make it across the street before the signal turns back to green. So let's go ahead and wire those states up. And just like in the flashing state and in the operational state, we're going to use delayed events to cause the transition from state to state. Cool. So let's think about this. So if we go into the operational state, we're going to start in the green state. After 2 seconds, we're going to jump into the yellow state. And then after another 2 seconds, we should transition to the red state. The red state is going to have an initial child state of halt. From halt, we wait 2 seconds, and then we're going to go into the red walk state. After another 2 seconds, we're going to transition from the red walk state to red flashing. Now, I realize that I made a mistake here, and we don't want to go back to the halt state. Instead, after the flashing is done, we need to just transition back to the green state. So we're going to take this and move this up here. So let's go ahead and simulate this and make sure that this is working correctly. As you can see here, we go from the operational green to yellow to red and back to green. Now within red, we're actually going into the red halt, red walk, and the red flashing state. This is awesome. This is exactly what we want. But we need to consider, what if there is no pedestrian at the intersection? We shouldn't have to extend the red light if there is no pedestrian there to make that cross. So we need to add conditions here. We need to have a conditional transition. So this is where we're going to add a guard to check to see if there is a request to cross the street. Okay, so how do we do this? So we're going to want to do a conditional transition from the red halt to the red walk state. If there is a request to cross, we want the red halt to go to the red walk state. But if there is no request to cross, we just want the red halt to go directly back to the green state. So what we're going to do here is we're going to add a guard to this delayed event. Okay, so if the pedestrian requested to cross, we want to jump into the walk state. Otherwise, we want to go back to the green state. So let's make sure this is working correctly. After 2 seconds, we go into yellow. After 2 seconds, we go into red. Now here in the halt state, we check after 2 seconds if there was a request to cross. If this is set to false, it should go back to green, which it is. Now, if there is a request to cross, we want this to transition to walk. Sweet deal. Now, let's go ahead and copy this code from XState and copy this over into our application that we're going to build. So we can come here. So we're going to copy this, and I already created a workspace for us to build this application out. We're going to create a new file, and we're going to call this traffic machine. And we're just going to paste over what we copied from the XState visualizer. All right, so what needs to happen next? We need to start wiring this up to our application. We're going to use SolidJS and XState Solid for this app. Cool. So let's jump into the app component. And what needs to happen is we are going to start building out 2 components. We need to build the traffic light component and the pedestrian signal component. So we're going to import a few things for our component. So we're going to define the props that this component is going to receive, which is the actor ref. This actor ref is created by the state chart that we defined earlier. Now that we have the traffic light defined, let's go ahead and create this actor ref. You need to pass that actor ref to the traffic light component. Cool. Now we have our traffic light component and it's working. We have the transition happening from the red state back to the green state to the yellow back to red. Awesome. Now the next thing we need to work on is the pedestrian signal. Let's go ahead and create that component next. The pedestrian signal is also going to take the actor ref. Remember, the actor ref is our single source of truth for the state of our application. So we need to import a few things for the pedestrian signal as well. And we're also going to create the same prop for this component. Now, let's quickly touch on this syntax. When we use XState, we need to provide an object to tell it what state we're actually checking for. So in this case, we're checking to make sure that we are in the operational red walk state. And we're using this with classless from SolidJS to dynamically change the style of the component. Now let's go ahead and import the pedestrian signal to display it on our UI. Cool. We have a few things that we need to fix. The pedestrian signal is flashing. As you can see, there's a red box for halt, and there's also a green box for when the pedestrian is walking. But what I want to do here is I want to make sure that we're also displaying an icon for this. So let's go ahead and fix that. We have a hand and footprint component that we're going to use. So let's think about this. If the state matches the walk state, we want to display the footprints. Otherwise, we want to just display the hand for every other state. So let's go ahead and do that. We're going to check for this operational red walk, and we will display the footprint component. Otherwise, we're going to display the hand components. So let's go ahead and refresh this UI. Awesome. Now we have the red icon displaying and the footprints displaying. When the traffic signal is on red, we get a brief chance for the pedestrian to cross the street, which will display the green background with the footprints. And then you also see here that temporarily we have the flashing state that alerts the user to cross the street. Nice. So what's the next thing that needs to happen? We need to go ahead and build a button that we're going to use to send an event to the state machine. This is going to send the request to cross event that's going to allow the pedestrian to safely cross the street. Right now, our state machine is set to default to true. Now, that's not always the case. If there is no pedestrian at the intersection, we don't need to extend the red light. So let's go ahead and fix that. So underneath the pedestrian signal, we're going to add a button here. And we're going to keep track of the is requested flag. And we're going to use the actor ref to send that event. And we're going to send the request to cross. Now, TypeScript is not happy with us because we haven't defined that event and we haven't defined that in the context of the state machine. So let's go ahead and fix that. In the context, we need to keep track of this flag. We need to keep track of if the request to cross has been submitted by the pedestrian. We're going to default that to false. Now let's refresh this and see if that made any difference to our state machine. So you can see here, we're still going into the halt, walk, and flashing state. So we need to go ahead and add this condition. We need a conditional state transition that's going to happen in this red state. Now let's go in the red state and try to figure out why this is still happening. So we see here, our initial state for the red state is halt. After 2 seconds, we're going to target the walk state. And we already defined a requested to cross guard for this state transition, requested to cross. So if we go back to the top of the machine, if we check our guards, we can see that the requested to cross guard was already defined, but we have it hard coded for true. So let's test this out and flip the flag, and let's make sure that we're no longer going into the red halt, walk, and flashing state. Now, when we're in the red state, we go back to the green state right away. But we don't want to manually update this flag. We need to get that from the context of the machine, which is basically the memory of the machine. So in our context, if you remember, we're keeping track of this active pedestrian crossing flag. And that's what we're going to use to drive the behavior of the pedestrian signal. So now we need a way to update the active pedestrian crossing flag from this request to cross button. We still haven't defined that request to cross event, so let's go ahead and update that now. Cool, so now we have to consider, where do we want to call this event from? So if we're at a traffic light and I'm a pedestrian, I want to be able to request to cross if the traffic light is functional, if it's operational. So anywhere in the operational state, we should be able to call this request to cross event. So we're going to jump into the operational state, and you'll notice that we already defined an enter flashing mode event earlier. So this is where we're going to add that event. And now when we request to cross, we want to update the memory of the machine. We want to update that active pedestrian crossing Boolean to true. Cool. So let's add one more final touch. Underneath here, I'm just going to add a details so we can display the state of the machine and the context of the machine so we can see that live. So now you can see the state transitions that are happening, and we can see that the active pedestrian crossing is going to update to true if we click this button. Now that that's true, the pedestrian states are now active. Cool. So now we spotted another bug. We forgot to reset the memory. So once we set it to true, we also need to make sure that this active pedestrian crossing gets set back to false. Otherwise, this is always going to be disabled. So now let's think about this. When should we reset this flag? I'm thinking whenever we go back to the green state, we should reset this. So what we're going to do here is on the flashing, you see here that we go back to the green state. We also want to go ahead and add an action here. We're going to update the machine's memory and tell it that the active pedestrian crossing is now set to false. So now when we request to cross, the button is disabled. When we go back to green, we should see this enabled. Cool. And there you have it, guys. This week, we went over a traffic system. We learned about hierarchy and state charts. As you can see for yourself, the code came out super clean. Let's look at those components again. We have a single actor that we're using as our single source of truth. And then we pass that actor ref to those two components. This is amazing because our components are pretty much in sync all the time. All right, guys, if you enjoyed this video, please leave a like and subscribe, and I'll catch you in the next one.